Assalamualaikum and hi, my name is Muhammad Zulfaran bin Rasid, and today our group will be presenting about the topic of offshore platform and onshore plant. Before we going further, let me tell you about the overview of oil and gas. In Malaysia, the oil and gas industry is very important because it supports the country's economy and contributes about 20% to the national GDP. This industry helps provide fuel, electricity, and other daily needs. The oil and gas industry is divided into three main parts, which is the upstream, midstream, and downstream. The upstream and midstream sectors involve searching for oil and bringing it to the surface, often using offshore platforms. These platforms are built in the ocean and are strong enough to handle bad weather and deep waters. The downstream sectors involves processing the oil into useful products like petrol and diesel. This is done at onshore plants using special equipment such as the distillation towers and heat exchangers.
Hi, I am Nur Ilia Hidayati binti Saiful Bahri, and I will continue on the literature review. Under this literature review, we will be presenting on the introduction, type of refineries, design aspects, construction techniques, force work and support systems, material use, and cost consideration. Next is types of refineries. Refineries are categorized based on their processing complexity and product output. The five main types including first, simple refineries. These use basic atmospheric distillation and are common in regions with low demand and minimal regulation. They produce a high share of low-grade fuel oil and have limited flexibility. Next is hydroskimming refineries. An upgrade from simple types, these include hydrotreators and reformers allowing the production of cleaner burning fuels that meet international standards. Next is the conversion refineries. These incorporate catalytic cracking and hydrocracking to convert heavier oils into lighter, more valuable products like gasoline and diesel. Next is complex refineries, the most advanced type combining features of the previous categories with additional units like alkylation and petrochemical integration. These are designed for high efficiency and strict environmental compliance. And lastly is the modular refineries, smaller prefabricated unit designs for remote or underdeveloped regions. They are cost-effective, rapidly deployable, and can be scaled up as demand grows. Next, let's look at the key design aspects of modern refineries. Whether traditional or modular, design today is centered on improving efficiency, safety, and sustainability. Firstly, structural layout is critical for safe operations and future expansion. Traditional plants are spread out for hazard control, while modular refineries use compact, skid-mounted units for fast setup. Next is process integration has advanced with energy-saving techniques like pinch analysis and hydrogen optimization to improve yield and reduce emissions. And lastly, digital technologies such as AI, digital twins, and modern predictive control now help optimize operations, reduce energy use, and extend equipment life. Lastly is the construction techniques. Construction approaches vary significantly between offshore and onshore facilities, driven by environmental conditions and engineering requirements. Firstly is offshore platforms. These use fixed structures like jackets and gravity-based systems in shallow waters and floating platforms like TLPs in deeper regions. Suction caissons are used for foundation in deep water and modular fabrication, where modules are built onshore and assembled at sea. It helps reduce offshore construction time and improve safety. Corrosion protection, cathodic systems, and compliance with international standards like API, like API RP2A are vital for long-term durability. On the other hand is onshore plants. Construction has shifted from traditional stick-built method to modular construction, where components like distillation units or pump systems are prefabricated and installed on-site. 3D modeling and crane planning tools improve logistics and safety. Onshore plants must meet ASME and API standards and integrate complex piping and instrumentation systems. Digital tools such as AI based on monitoring and digital twins are used not just during operation, but also throughout the construction phase for better planning and risk management. Environmental systems like flare control and Emission treatment are also built into the construction process to meet regulatory demands.
Next, for forcework and support system. In offshore construction, forcework and support system are temporary structure that provide stability and safety during the building of platforms. These systems are crucial because offshore environment face strong wave, wind, and sea current. So for fixed platform, jacket structure, forcework like guiding frame and drilling template is used to align and support components before they are permanently installed. So for floating platforms such as TLP, it is like lifting frame help keep the structure stable during positioning. In subsea system, forcework such as template and guide frame help accurately place heavy equipment on the seabed with the help of the diver. So overall, forcework ensure accurate placement, structural support, and worker safety during the early stage of offshore platform construction. Next, material use. So offshore platform require material that are strong, long-lasting, and resistant to corrosion due to harsh sea condition, where different materials are used based on the part of the structure and its exposure to the water. So first, the steel were used for jackets, decks, and frame, where it is used for area under heavy stress, where the steel need protection from rust using coating, galvanized finishes, or chaotic protection system. Second is concrete, where it's mainly used in gravity-based structure (GBS) that rests on the seabed. It is often reinforced and has a good resistance to seawater, where it is very protective barrier. Lastly is composite materials, where it is like fiberglass reinforcement polymers are lightweight, rust-proof, and used for ladders, railing, and panels, where used in pipeline and cable protection system because they are resist marine growth and chemicals. So to protect the material, special coatings are needed. So it is help anti-fouling and anti-corrosion coating to extend the lifespan of underwater parts. So the new materials like smart coating and nanotechnology are also being developed for better durability and sustainability in deep sea conditions. Next, cost consideration, where offshore platforms are among the most expensive structure to build due to their remote location, complex design, and harsh environmental condition, where managing this cost is crucial throughout the entire life cycle of the project from design to decommissioning. First, for the water depths, generally fixed platforms are more cost-effective in shallow water, while floating platforms needed in deep water, where it is more expensive due to their complex mooring and structural system. The material selections also influence the cost, where we need the high quality material, where it costs more initially, where they reduce long-term repair and maintenance costs and extend the platform lifespan. The third one will be the transportation and installation, where the special vessel and equipment are needed to move and assemble the large structure offshore, where the delays due to bad weather or poor planning can further increase expenses. Lastly will be operation and maintenance (O&M). Majority of long-term costs of the platform life cycle costs, where regular inspection, part replacement, and eventual decommissioning require careful planning and budgeting. So overall, to reduce costs, companies are now using modular construction and digital technologies like BIM and digital twins, where it can improve the planning, reduce error, and speed up the construction, and also help to keep the project within the budget.
Assalamualaikum and hi, I am Abaiman Hasik and I will be presenting on case study Petros Gas Hub in Bintulu. The Petros Gas Hub or PGH is located in Bintulu, Sarawak and integrates gas processing, distributions and petrochemical operations in one site. It's managed by PC Sabah, a Petronas subsidiary in collaboration with Petros Sarawak State Oil and Gas Company (PGH) aimed to enhance state control over gas supply by limiting exports from non-local firms and ensuring cleaner gas reach local industries and power plants. Its central location reduces transport delays and costs, while future connections to offshore and onshore fields support Sarawak's energy growth. Construction started in 2022 with phase one including pipelines and terminals. Full completion is expected by 2025, but the hub is already supplying gas locally. Beyond energy, PGS supports Sarawak's sustainability goals, creates jobs, and positions the state as strong player in the gas markets. Parties involved in this project are Petros. Petros is the project owner and lead developer. It is responsible for overseeing the overall planning, engineering design, construction management, and eventual operations of the gas hubs. The company ensures compliance with safety standards, coordinates contractors, and manages gas distributions across Sarawak. The second party involved are Sarawak State Government. The Sarawak State Government provides strategic oversight, policy directions, and regulatory approval through agencies such as the Ministry of Utility and Telecommunications. The government ensures the projects aligns with Sarawak's energy sovereignty goals and sustainable development plans. The third parties involved are local and regional contractors. Companies such as PPES, Works Sarawak, Shenyang, and other Sarawak-based contractors are involved in construction works including civil engineering, mechanicals and electrical systems, and pipelines installations. Their involvement supports local industry developments and fulfills the state's local content and Bumiputera participation policies. The parties involved in the gas productions or production sharing contractors, in which the raw gas is supplied to the hub from offshore field operated by key PSCs, including Petronas Carigali Sdn Bhd, Shell Malaysia, PTTEP Malaysia, Murphy Oil Sarawak, and Incas. These companies extract and deliver unprocessed natural gas under production sharing contracts, which is then received and managed by Petros. The gas consumers and industrial users, where their role is processed gas from PGH is supplied to various end users including Sarawak Energy Berhad, power generation facilities, and industrial located in Samalaju industrial parks. These consumers benefit from improved energy reliability, cleaner fuel options, and potentially more competitive gas pricings. The parties involved in Another parties involved in these projects are regulatory authorities. Regulatory compliance is ensured by agencies such as the Departments of Occupational Safety and Health (DOSH), Natural Resources and Environment Board (NREB) Sarawak, and the Departments of Environment (DOE). These authorities oversee project safety, environmental impacts, and adherence to both federal and state level regulations.
Next, I will talk about heading 3.3 to 3.5 for the case study. First is the major components. It consists of gas processing and compression. And next is trunk line and pipeline network. Next is metering and control, storage and buffering, and lastly is supporting infrastructure. For 3.4 is the construction process. They start with site preparation and then they go with modular installation and then followed by EPCIC contract, which stands for engineering, procurement, and construction. And lastly is electrical and instrumental. For 3.5, it is the materials that used in this case study. Firstly is piping, and followed by reinforced concrete structure. And for the wiring and cabling instrument, they use copper wiring and fiber optic cabling, and also include hazardous area enclosures. And also there is fire protection such as intumescent and coatings and non-combustible insulation. And lastly, in order to keep up with sustainability. They include low VOC paints, lead-free coatings, and also recyclable packaging.
Moving on, next is the challenges and resolutions. For the Petros Gas Hub in Bintulu, there are various challenges faced by the company. The first one is the pipeline decommissioning. The 500-kilometer long pipeline that transports natural gas from Kemani Sabah to Bintulu Sarawak reported to have frequent leakage, in which one of the incidents led to a fatal one. This problem may cause Petros and other companies that benefits from this pipeline to lose some of their profit. So, as to mitigate this problem in the future, these companies may need to implement a monitoring system where it can detect possible leakage. By doing so, any unwanted incidents may be mitigated in the future. Other than that, there is also the disputes between Petros and Petronas over claims over gas rights and operations. These disputes not only causes confusion and legal conflicts, but also disturb the daily operations and progress of oil and gas projects in Bintulu. Fortunately, the disputes have been resolved peacefully, where the both parties mutually agrees to acknowledge Petros as the sole gas aggregation in Sarawak. Next is the environmental concerns. This kind of project, where it involves drilling of seabed to find crude oils and processing of crude oils into other products, have significant impact towards the environment. The impacts include global warming due to carbon and methane emissions, and endangerment of animals due to loss of habitat from land use changes nearby ecologically sensitive areas. To resolve this problem, the Department of Environment instructed Petros to conduct environmental impact assessment to ensure mitigation of environmental harm while complying with national regulations. The last challenges that is generally faced by the current industry is shortage of skilled labor. This shortage in Malaysia often relies on foreign manpower, causing high operational costs due to imported skilled labor. In order to solve this problem, the oil and gas industry may need to do collaborations with the academic institutions across Malaysia, including Sarawak. By doing so, it would intrigue young generations to further their studies or develop their expertise towards the oil and gas industry, thus increasing the numbers of skilled laborers.
Finally, we will talk about the conclusion. For the conclusion, the key takeaways is firstly is strategic milestone where it symbolizes Sarawak's ambition for greater control over its natural gas resources. It also supports cleaner fuel supply for local industries. Next is integration of offshore system and onshore system, and they also overcame challenges through planning and technology. Lastly is they support economic growth and environmental protection. And also came with conclusion is the recommendation where firstly they will prioritize safety via IR 4.0 technology, where they will adapt sensors, AI, and real-time tracking for predictive safety management and also enhance hazard detection and prevention of accidents before they occur. Second recommendation is resolve legal disputes through negotiation. For the dispute, they should be solved through negotiation and also ensure smooth operations and prevents project disruption. Finally, is strengthen the environmental compliance and sustainability, where they will comply with environmental laws and adopt low emission practice, and also safeguards biodiversity and contributes to sustainable development. That's all from us. Thank you.